All right. Hello, everybody, and good day, and happy to have you here with us today. This is Scylla Virtual Workshop. It is a twice monthly series, which will be held on Fridays at 10 a.m. But this one is a little bit different. This is our end of the year session in which we'll change a little bit the format and make sure that it is fun and happy for everybody. So before we started, we would like to review a couple of items. One, we welcome your questions during today's workshop. Please use the Q&A panel located at the bottom of the viewing screen to ask any question you have at any time during the broadcast. We will answer your questions at the end of the sessions, those questions that belongs to the end of it. You'll see this one is a little bit more interactive, and we'll make sure that it is fun for everybody. Also, we are recording this session, and we'll send the recording of the session at the end of this workshop, so you can actually review it with yourself after these sessions. And with that, I want to mention one more thing. We have our Scylla Summit upcoming on January 12th, 13th, and 14th. And I ask you that you register to this virtual summit. I'll have a slide for that at the end of the session, so you can have the link from that one as well. And with that, I will hand it off to our first presenter.
Hi, my name is Moreno Garcia. People call me the professor, and I'm a man with a plan. The plan is to help you deploy and be successful with ScyllaDB. I'm not planning a money heist, by the way. But if for some reason you run into serious problems, we can activate Chernobyl and make things right.
I'll move to the second introduced presenter here. Mahi, go for it.
Hi, I'm Mahidar. People call me the wise guy. Basically, if you run into any issues, I'm the one who's going to be coming in and helping you fix it. So I got your back, trust me.
And I'm Eyal Gutkind. I'm not a gambler, but I do have a lot of resources that I can give you and help you deploy Scylla. So if you run into an issue and you need some resources, whether it's one of our solution architects, help with support and other items, I'll be more than happy to help you. My goal is to make sure that you have the best experience using Scylla. So by all means, please reach out to me and for any resources that you need. I'm Eyal Gutkind. And as we promised, you should have your drink with you. I have my own jar of vanilla tea. So get a sip, enjoy yourself, and let's start with this. So this is us in real life. This is how we look like on the pictures, and you can see our faces also on the camera. So how this whole session is gonna work. The agenda for today, we're gonna share with you stories that we see day in, day out. Every day that goes by, we see more and more stories about how to deploy Scylla, how people use Scylla on their use cases. We'll show you the real examples. We'll ask you to participate, and you can win prizes. Our team will reach out after the session to the winners of the sessions. You will be able to post your answers to questions that we will ask, and the person who has the most correct answers will be reached out by our team to make sure that you get your prizes with. Should be fun and should be happy to participate. So again, presenting a real-time scenario, you will see after we post the scenario, you will see that there is a polling question up on your screen. We ask you to push the button for the answer that you think it's the most appropriate for that specific use case. Once you provide the answer through the poll, we will actually reveal what truly happened or what is the real reason for some issues that you see in the field when you deploy Scylla, or how can you benefit from a better performance from using it. But before that, I'm gonna have 2 slides just to an overview to provide you the walk into the process of how this session is gonna work for you guys. So the first thing about us, we are the team behind Scylla, the real-time big data database. Scylla is a drop-in replacement for Cassandra and DynamoDB applications, but provide you 10 times performance and low tail latency. We are available on the cloud and on-prem with both open source and enterprise editions. So if you haven't already, I highly encourage you to try and use Scylla. The next slide, you might have seen it before. but it just makes sure that, put you into the mode of what we're going to be talking about. Think about those four pillars of benefits of Scylla. All of them are going to be introduced in the questions that we're going to ask and you're going to participate with. So the first one is the reduction of number of nodes that you need in order to support certain application workload. Scylla scales up philosophy is to use fewer nodes and larger nodes for your workload. It will provide higher operational efficiency and for sure a better performance. Second, when you control the application's latency, you control the user experience. Scylla, being closer to the hardware, is able to provide on a well-sized system the same level of experience for your application users along the way. It doesn't matter whether you have small number of users or high number of users, you will see the same experience. The predictable and low tail latency help you serve more customers and lower the cost of infrastructure at the end of the day. Third one, installing and maintaining Scylla is a simple task. There is no long cryptic configuration files. Scylla auto-tune itself to the hardware you are using, saving you time and prevent you from error-prone procedures that you need to find in order to have the right settings. And the fourth and last one, compatibility. Without changing a line of code on your Cassandra or DynamoDB API application, you can move to Scylla. You can provide you a lock-free environment, and we support your original drivers and the application code that you're using today. And with that, let's play. This is the fun part. This is how we start. Okay, so the first one is, this is the scenario that we gonna have showing to you. The first one is, we are using, many of users are using Spark together with Scylla, okay? So this user comes to us, hey, I have 3 workers of Spark connected to Scylla cluster, and the result looks okay in terms of correctness. But I'm expecting more. I was expecting a better performance coming out of Scylla when it is connecting to Spark. Something doesn't look correct from my perspective. So my question is, for you is, we want to debug this session, okay? We went to the debug session, we want to understand what to look into. One tip I'm gonna give you is that we're looking at the load. So there is, if you know Scylla monitoring, it has a load chart, and that load chart shows an almost complete idle cluster from our side. So with that, if we can pull up the first poll, the first option that you have is looking into the CPU temperature. Maybe we're running at a very high temperature on the cluster. Second thing is look into the connection pooling and concurrency enabled from the client side, okay? Maybe there's something is not connected properly. Look into the compaction workload. Maybe we have a compaction workload that actually hinders behind him a very substantial workload that we should not be seeing in our use case. And the fourth one is look into streaming. Maybe we're streaming a node. Maybe there's a repair process that holds back the actual workload from being able to accomplish what we need to do. So that's another option that we can look at. I'll give you another minute and something to munch on the possible options here. Meanwhile, my colleagues and I will chat. So Moreno, what would you look into? The first option that comes into mind, to your mind.
I would not look into the CPU temperature.
You won't. Sure. Maybe we can fry some eggs on that one. Money.
I don't even know how to look at the temperature of a CPU. Like, you just do an infrared temperature. But some more.
That's very trendy right now, right?
Yeah. So, but more importantly, I think it's important to look into what kind of workloads are going on the system, and really try to understand, debug it from there.
So yeah, I got your point. Yeah. Temperature probably is not the one, and I can tell you, probably is not going to get a lot of attention or love from our users here on this workshop. And I agree with you. That's the non-anchor answer on this one.
Let me just remind people, if they don't vote, they don't get prizes. But I see people are really engaging on those questions.
Yeah. Ooh.
Vote, please vote. Don't boo.
So, yeah.
Okay. Give it a shot,
Yeah, we closed this, we closed the poll. Those are the answers that you had. Let me tell you exactly what happened here. So most of you answered pretty right. In order to make sure that you have a balanced cluster, you need to look at the connection pooling. So you have to look at how many connections are opened between your clients and the Scylla servers. What we see here is that we have a very slow connection coming in from the clients. By default, they will open a 1, and that's going to be hampering your ability to push data into the cluster. So I highly encourage you to look at the connection pooling and how many threads you're opening from the client side in order to utilize the process that you have in Scylla. By the way, if you are using the Scylla shard-aware driver, you are relieved from the need to look into those metrics, because Scylla shard-aware driver will be able to show you exactly how many connections can be opened from your client side into the Scylla node, because again, it's a shard-aware driver, so he gets the configuration, he gets the technology, he gets the infrastructure that you're using within Scylla to make sure that you get the right answer on that one. So that's the idea that we are going to ask you to look at. Again, the connection pooling is an important point to look into when you're deploying Scylla. Again, it both on the client side as well on the Scylla side, that you can look at those connection pooling creations. Any technology you can be using, Java, Python, Rust, Go, has an ability to create a number of connection pools into the client itself, into the server itself. So please use those every time. And with that, I'll move it to Mahi Jason here for the next one.
Yeah. Yeah, that's a very important point, y'all. Thanks. Use the shard-aware driver. You don't have to worry about the number of connections. So let's go through another scenario here, right? Let's say your team is building a system to hold some temporary data, maybe for 3 hours or so, where you have to run a few aggregates on this data, and the SLAs for running these aggregates, you need to read a whole bunch of data. So you're doing a lot of reads. While you're doing a lot of reads, you need these P99s to be less than 10 milliseconds. So that's a pretty tight SLA, very high ask. But then you also look at your patterns that 95% of these queries are repetitive. They're accessing repetitive data. So it's not like you're reading new data every time, but you're reading the same data every time. So if this is the kind of scenario and you're starting to run this in Scylla, what kind of metrics will you be looking at when you deploy it with Scylla and you're looking to maintain your Scylla cluster? What are the metrics you would be looking at? That's the question. So yeah, the options are, you will monitor the number of connections created. You will monitor the write bandwidth. You will monitor the caching layer metrics. You will monitor the reverse query metrics to make sure your partition scans are properly set. So these are your options. And yeah, what do you guys think?
Yeah, I think that not every problem is a nail, so don't go with the hammer on the connection thing. That's the tip that I would give you.
Yeah, we kind of induce people to the wrong question with the first scenario, right?
But don't go for that. That's one. So you already have a better chance to go right on 30.
You've already given them 25% advantage.
Yes.
Yeah. It's supposed to be fun. Have to have fun, Mahi. Come on, we have to make sure that people engage with us on those questions.
Yeah.
So yes,
we're not testing people. We're sharing information with them.
Okay, so yeah, so guys, I mean, typically, I mean, if you have a team, it's always good to sort of go through these scenarios like how we're going through. They're just going to maximize your chances of maintaining your cluster, being in better shape. Maybe you might even get prizes, like how our marketing team might send out if you get all your right answers. So, okay, okay, great. So All the answers are in.
Yeah, all answers are bad. All bets are off at this point. And this is what really happens. So look at the monitoring. Go ahead.
Yeah. So it's most important to look into the caching profile. Basically, as I've said, like, these are the things which you would look at. You have reads with misses and you have reads with no misses. So these are the two things which you would look at. And also then you would look at the row hits and the partition hits and the row misses and the partition misses. Typically your workloads are all reads, and 95% of the time it's the same data which is being read. So you'll be in a very good profile, but all of a sudden you can see some spikes. You see those row misses, there are some spikes, and partition misses, there are some spikes. So when you're seeing those spikes, basically that means that maybe you have a large partition that you brought into memory and data got evicted. Or maybe you're reading some other data which is not in your typical 95% of your profile. So that typically causes evictions. And as you can see, like there was some fairly big spike of partition evictions and row evictions here as well. And sometimes this results in some timeouts because data has to be fetched from disk. So these are the kind of scenarios you would be monitoring and trying to understand and profile. Okay, great. So we at least have 12 people who answered it right. So let's go to the next scenario.
Let's go for the next scenario. Go for it.
Okay, thank you guys. So one of our users deployed a ScyllaDB node on GCP using those N2 HighMem4 instances and did some functional testing. So basically he was, playing with drivers, creating an application, schemas, inserting some data. After he was done with it, he cloned that machine to N2 HighMem16, which are 4 times bigger, right? And ran a benchmark that yielded very poor performance results. What was the recommendation he got from the Scylla team on the user Slack? And by the way, this happened just like 2 weeks ago. Let's go to the answers. So wait for cache to fill up. You need cache to be full to get good results since Scylla is an in-memory database. Next is spend more time tuning your JVM for this particular workload and you get much better results. Next is check out our best practices and use more connections, threads, and deep dive into the benchmarking tool documentation. Fourth is run Scylla setup and do a rolling restart of your nodes. And the last one, use a more traditional relational database because we all know they have better performance than most NoSQL. Oh, people are really excited about this one.
The fifth one, come on, Moreno. What did you put it down there? We are a NoSQL database at the end of the day.
I was just, trying to make it easier for people.
Okay, so now you reduce the options by another 20%. Okay, don't go for the fifth one. Exactly. That's
be careful. Moreno is very tricky.
Yes, it is tricky. But those are good examples. So think about it. The user was actually seeing good results with a smaller instance. Moving to the bigger instance, it was unable to get the comparable increase in performance. And that triggers him to come up and ask questions about, hey, how come things didn't go as I planned for? And
it's basically, hey, I got machines that are 4 times bigger. Why I'm getting the same poor performance from a small machine, right?
Correct. So guys, don't be disheartened. Punch one option. You cannot be wrong here, to be honest.
Take a guess.
At least 2 good answers in this one that can help you out understand exactly how to look at how resources are being built within Scylla and what's the benefit you're going to be getting from scaling up, as we mentioned. And as I mentioned in the beginning, that's the idea. How do you scale up your system and getting the benefit from that system?
Yeah. Just almost always, scaling up gives you better performance on Scylla than scaling out. But a lot of times you also have to understand, I mean, not everything is very uniform. I mean, sometimes you're probably going to be using, OpenStack, VMware, like we don't know. We would definitely want to understand more about your scenarios.
Absolutely.
And the right answer is
run Scylla setup and do a rolling restart of your nodes. And let me explain this. So when you install Scylla, Scylla benchmarks your hardware and tunes itself so you don't have to do any tuning. Because the user had previously installed and configured Scylla in a smaller instance, when it was cloned, it carried on all the config files, into the larger instances. So the settings were wrong. So when you run Scylla setup again, it will take another turn at benchmarking your hardware. It will write new configuration files and use those settings after you restart the nodes. In this particular case, he went from machines with 4 CPUs to 16 CPUs. He added more NVMEs because that's our recommendation using RAID 0. So after you run Scylla setup, Scylla will know that you have more CPUs, that you have more I/O, and will take advantage of that. By the way, if you chose the option about checking out best practices, etc., you are not wrong. But first, you need to check if your Scylla configs are correct, and if that's okay, everything is as it's supposed to be. Then you look on the client side, which is kind of the case that Eyal presented with Spark, right? So you had two great products, but you had a bottleneck on the client side. In this case, the bottleneck was on the Scylla side.
Yeah, and also maybe Moreno, if you don't mind, I mean, maybe you can speak
Absolutely.
about what happens in Scylla setup for I/O. Like, I mean, what happens?
Yeah, I think we are providing a link about all these tunings, but basically what Scylla is doing is learning what's your hardware. So we'll check CPUs, memory, networking, disks, pretty much everything, because we are C++, we are close to the hardware, right? So after we know that hardware, we can squeeze every bit of resource from all those different parts. And that's exactly what the user did. If you go to Slack right now, I'm pretty much the thread is still there. And he was pretty happy after he just did this simple procedure. Run Scylla setup, restart the nodes, boom.
Let's move to the fourth use case. And this one is slightly different, okay? So it's more about, okay, how do I think about capacity? How do I think about cost? How do I think about migrations? What do I do in those use cases? In this specific case, a team was tasked to move away from DynamoDB because of cost. DynamoDB is a good solution out there at the end of the day, but they have a tremendous amount of read-write units consumption. So they consume a lot of resources from Dynamo, and it costs them a lot. So after Googling a little bit, the operator, the DBA, came up to us and said, okay, what should they report in terms of possible savings moving from DynamoDB into Scylla? Don't forget, Scylla also offers you the same API on a managed service on our Scylla Cloud, as well as on the on-premise solution that you can deploy. So both options can be there. So you should think about, okay, what is a reasonable number of possibilities that I can have here? And let's see, you can have roughly 80% of savings. Scylla and Dynamo will cost the same no matter what you do. That's another option. We should abandon DynamoDB completely. Maybe that's another option that you can give us. Or DynamoDB is not relevant for you. Just punch that one if you're not interested in that one. If you think about it, maybe a larger number of operations, DynamoDB can be actually cheaper than Scylla. That's a possibility as well. So think about those possible scenarios and what you think should be the answer. So the idea with the DynamoDB API is to provide another transparent use cases for Scylla. So if you think about the DynamoDB API, it's a pretty simplistic API that people are using for putting and getting data with some attributes attached to those informative pieces of data. And it's a tremendous use case, or an actually excellent use case for us to use in order to make sure that we provide that efficiency that we provided for users who needed the CQL layer enhancements. You get the same benefit. You get the replication factors, you get the multi-DC, you get the secondary indexes, capabilities. All those are already existent with Scylla, so you can take advantage of those with your DynamoDB API as well. Again, it's the same port, same drivers, everything is the same. But the idea is to save you money on those deployments when you use DynamoDB. It can become pretty expensive as you go along with the increase of operations per second that you push in and out. One more thing you have to think about is, and we also did some a webinar a few weeks ago, the total cost of ownership when you use different cloud offerings, what you should consider in terms of cost for those items. Feel free to reach out to us and understand exactly how we can save money. And with that, let me move to the right answer. So the right answer is roughly 80% savings. What we see as you scale up with the operations per second, the cost of operating DynamoDB becomes almost imperative. I highly recommend that you look into the different cost structures that you're using. If you're using, for example, a very low operations per second, extremely low, with a lot of data, at that point, DynamoDB can actually become cheaper than Scylla to operate. That's the case. But if you have a substantial number, few thousands of RUs or write units that you consume, then Scylla becomes a very, very, very efficient product as you scale in the operations per second. Even if you don't scale on the storage side, you will see better and better benefits using ScyllaDB over DynamoDB, getting the same APIs, getting the same capabilities, getting the same interaction with your clients that you do today. So think about those benefits. Again, as I said, the larger amount of operations per second, the greater the savings will be from your side. Any comments, guys? Feel free to jump in.
I think this just speaks, volumes about what we call the Scylla engine, right? So our core product. We implemented the Dynamo API because we saw that we are so efficient that, well, why not implement other APIs that, can be a match for our engine, right? And that's exactly the case here.
Yeah. It's a very important point, Moreno. I think what Moreno was saying was Scylla is built on top of the C* framework, and C* framework, we understand that it typically any database out there, NoSQL database out there, consists of commit log, mem table, streaming, compactions, and few jobs which are similar across, like controllers and so on. So these are similar across all databases. Every database has the same functionality underneath. So we started supporting. Initially we started with Cassandra API, and now we have Dynamo API in the future with planning Redis and so on as well. You still get to use the same engine, the C* engine underneath, while supporting different use cases, all while actually saving customers maybe more than 80% TCO. We have a number of customers who moved from Dynamo using the Alternator API, as well as some people have also started completely moving from Dynamo to Scylla API. And also, I should mention that our Dynamo API Alternator is available on Amazon itself on their Outposts, which is if you have a private cluster deployed somewhere, you can use Scylla's Dynamo API instead of Dynamo.
Perfect. Right.
So with that, before we go to the next scenario, there's a question here on questions and answers about the scenario 3. After scale up in GCP, do we need to do rolling restart of ScyllaDB? It will not take care of it automatically. By the way, usually on these scenarios where we are migrating or scaling up, our procedure is very clear about running Scylla setup. So if you just follow the procedure, it would be right. The problem with this user on users Slack, it's someone from the community, was basically that he cloned the machines and that took all the config files with it. So he didn't generate those files from scratch with Scylla setup, and that was the problem. But yes, usually scaling up is not a problem.
And with that, go for scenario number 5. Go for it, Mike.
All right, so let's see. So now, whenever you install Scylla, our typical recommendation is like, hey, you use RAID 0. But customers, different IT teams have different requirements. Some people use RAID 10, RAID 5, RAID 1, and so on and so forth. So what we recently saw was once we onboarded a new use case, we started seeing some read timeouts happening in the cluster. It was very odd, because we've been already reviewing the metrics for some time and everything seems fine, but we did see an increase in the latencies all of a sudden. So once we started asking them questions, they said like, hey, we recently added a new Spark workload to our cluster, and that's why, that could be one of the reasons why. And we started looking into what could have caused that. So what triggered us to suspect that the Spark workload could be the reason? Can you guess? Yeah, the poll is up. All right. So here are some options. The option, we saw an increase in the cache reads and cache misses, and so the evictions from there. We saw partitions coming from back of the monitoring server. So big sparks were flying from the servers, and things were going crazy. That was the result why we saw this. We experienced increased compactions and commit log delays and the IO activity, and that could have caused this. The number of SQL connections increased, and that could have caused this. So I think, yeah, I don't know, y'all. What do you think?
I cannot stop laughing from the sparks coming from the back of the monitoring server.
I would go fire department, come into the co-location and just put down the server. That's what
it can happen. It can happen. I mean, Moreno has written a recent script recently, and I wouldn't be surprised if that script ran. Sparks would be coming from the server.
Me neither.
Guys, think about the Spark workload. How does it interact with the application, right? Most Spark workload are analytics, so they scan the data. So think about that.
Yeah, with Sparks, you get a lot of range scans and
exactly,
sometimes even full table scans, depending on what the user is doing, right?
Yeah, it reads most of the data. All right. I like how the answers are being given here. I think this one is a tricky one. It's one of the most tricky ones that we published on this session. Okay, yeah. But I don't get me wrong, I like it a lot, and I do like the answer, the one that the sparks are coming out of the back of the monitoring machine.
I think it's the funnier from all the scenarios.
Okay.
All right, so we got it down. So all 20 votes are in. So the third one is the right answer. So basically, you got to check for your SQL activity and your cache. So what happens in Spark? Like, as Moreno was mentioning, any Spark job typically results, a lot of times, if it results in full table scans, and when you're doing full table scans or range scans, there's a lot of data which is brought into the memory, into the RAM. And if you're not controlling that, it can be a flood of information, and that results in a lot of churn in the cache, and that could cause a lot of scenarios. And also some of the scenarios where you would see it is you use this key phrase, allow filtering. If there is allow filtering in your monitoring, that is a recipe that, hey, you're doing range scans. Sometimes you don't have an option, but you have to use allow filtering, which is fine. That is the reason why it is there. But sometimes if you can get by designing the data model itself, then you should. And also there's also another option which is only present in Scylla. We have this key phrase called bypass cache. So when you have your application as well as your Spark accessing data, and your Spark doing is range scans or sort of full table scans, and your application has its own memory profile which it's sort of maintaining it in RAM, then just Spark comes in and it just sledgehammers the data out. So data gets evicted out of your RAM, and you want to be able to control that. And if you use a bypass cache on your Spark jobs, your Spark jobs will fetch data from the disk directly, and they won't disturb the memory profile at all. So that is a very interesting feature which you should put into your workload. And that's how we resolve this issue with the customer, where neither their application workload nor their Spark jobs got impacted, and they were both running fine. Because even if your Spark jobs takes, let's say, 20 milliseconds, but now with bypass cache, it's taking 60 milliseconds. It's still fine. I mean, it's a Spark job. It's not time mission critical, but your application is very latency sensitive. So that's why we use bypass cache and resolve this issue. Anything you guys want to add?
Yeah, I would add one more thing. If you're using such a multi-user, multi-workload solutions on your cluster, use workload prioritization. It will help you maintain a certain SLA for each one of them. So you don't overcommit, whether it's going to be your Spark workload or your actual application client, overcoming the cluster and basically creating a starvation on the other application. When you use workload prioritization, you're going to create certain roles, and you're going to create a share-based system inside that system that will divide the workload and the resources in a way that each one of them will not end up without any ability to proceed. That's on that one. Moreno, if you had anything else.
Just took the words from my mouth.
Oh.
Workload prioritization.
Workload prioritization. Think about it, guys. Every time you deploy an application that has multiple users, multiple profiles, think about workload prioritization. It's going to help you to maintain the right SLA for each one of those workloads in a manner that does not interfere with the others. Yeah. So that's on that one.
Yeah, it's all possible because of the C# framework and how we have the custom scheduler. Yeah, basically these are two things which are Scylla only. You wouldn't find it in any other database out there: workload prioritization and bypass cache. Yeah.
That question, should I use your database for real time or for analytics? Both.
Both.
We can do it.
Yeah.
Both.
Yeah.
Just
I mean, so we are adding, I mean, there is a question in the Q&A section. So, but we are adding all these different features, which is competitive differentiation, which you wouldn't find in any other database out there.
Let me move to the last use case that we're going to share today. Moreno, go for it.
Okay, so a customer had a valid analytics case where he needed the count of all the records of a particular table once a week. He noticed that as his data set grew, the select count star from key space table grew until the point it would start to time out, right? What was Scylla's support recommendation to him? Let's go, let's see what are the options. First, change the read timeout to infinite. Create a counter table and modify your application codes to increase the counter every time you add records and decrease the counter when you delete records from the table. Use the node2 table stats command to get an accurate account of records. I think it should be count of records. Generate a script that leverages the token function and concurrencies so you have an accurate count that you can control the workload. And last, use Spark, Presto, or some analytics problem on top of ScyllaDB. Oh, that's a tricky one also.
That's a very tricky one.
Yeah.
Yeah.
That's me.
That's you, I know.
Sorry, guys.
Yeah, the first one, come on, it's not gonna happen. There is no way to put an infinite timeout. You want an answer at the end of the day, otherwise you're gonna just run into an infinite loop.
Yeah, and it's going to create problems for every other workload that you are running, right? Because now it's not timing out.
And more than, go ahead, my son.
Now you can always throw something into Ether and expect something, but you know, if it is infinite timeout, you're just throwing into, you might as well just RMRF that data. Like so.
You can always cut the red wire and hope for the best, right?
One thing, by the way, talking about infinite timeouts, think about the client timeout versus the server timeouts. There are defaults within Scylla. It's going to be 5 seconds for the reads and 2 seconds for the writes. Make sure that your client side is actually higher than those ratios. And the reason I'm saying that is because if you have a lower bar on the timeouts, the client thinks it times out, it sends the same request again to the server. So you're going to create what we call a retry storm. So you're going to retry and retry and retry, and at the end of the day, it's not going to end up well, because all those requests are going to get stuck in the server side and never being timed out properly to the client side. So again, I'm asking you, think about those timeouts. Timeouts should be properly set both on the client side, on the server side. We have best practices on our website telling you exactly how to do that. And we just publish also a production checklist to give you some more tips about going into production with Scylla.
Yeah, I think one important point I should add to what Eyal just said, like, is when you're retrying again and again, retry storm comes in, but also typically things like replication and all that is happening as a background operation. But with retry storm, what happens is all these operations are moved from the background into the foreground. And when you are monitoring this, you can clearly see that there'll be a huge spike in your background reads or writes and your foreground reads and foreground writes eventually. And that's almost always indicative that maybe there's any speculative retries happening, or your application is stuck in a retry storm. So you would always want to measure that. I mean, we are not covering that in this demo, but there's something which is important to think about.
Okay,
All right.
so we're done.
We're done. Let's go for the actual what the right answer is.
Okay, so the answer is official full table scans with Scylla. So we have an article. You get the link on our chat. So basically, by creating a custom script, you get not only the benefit of performance, but also full control over the concurrency, and hence over the impact that your parallel queries will have on your real-time workload. We've been talking about, analytics versus real-time. It ties directly to that. Another advantage is that you're not bottlenecking any shards that would have to be the coordinator, communicate to all the replicas, and so on and so forth for a full table scan. By the way, I said it was kind of a trick question because using counters, it's a valid use case for this. It's a valid solution for this use case. Using Spark or Presto are also valid, but they would require that you either change your application or change your data modeling, or that you have a completely new infrastructure. For in the case of Spark or Presto, now you need another product with other different machines, etc. For this particular problem, it was just a simple count. So simple solution for a simple problem. It can be implemented with just a few lines of code, and we are giving you also the links for a simple code in Python. Probably the one that Mahi mentioned, that it's going to create sparks on your server. and we have a Golang that it's much more complex, but you are going to understand those concepts much better. Anything to add, guys?
I think, again, if you have to do those type of workloads on Scylla, think about, as Mona said, the simple solution for the simple problem. Don't go crazy. We have on our website different options that you can do those NoSQL type of non-trivial actions on. Full table scan on a NoSQL system, it's a little bit of not an anomaly, but a different approach to the data. That's because you have no idea how much data is actually there in the table itself. It's not that you have that metadata inherited.
Yeah, and I think it's worth mentioning that the same principle that we are showing on the article and on these scripts, it's already implemented on something like the Spark connector, right? And
Correct.
then, as you mentioned in the beginning, if you're using the Spark connector, which already has that that brightness built into it, and then you add that to the shard-aware driver, then you're golden. It's going to be a very good result for your analytics.
Perfect. That actually completes our Q&A type of workshop today. It's the use cases and the scenarios that we have described with you guys. I have a couple more slides that I want to share with you. The first one is, a year in review, what we had on the last pretty extensive year, let's call it. It was a challenging year for everybody, I guess. So first, we really brought Scylla Cloud into a state that we can think about as a fast, smooth, and extremely reliable source for a managed service that you need for Scylla Enterprise. Go for it. Easy to use. We offer two varieties on it. One, it's called Scylla Cloud Our Account, so we use our AWS and GCP accounts, or Scylla Cloud Your Account, which is much more efficient because then you can take your bills for AWS and GCP and handle them separately from the Scylla one, and you are controlling the instances. So those instances are sitting in your cloud account, and we just manage the database for you. So we call it Scylla Cloud Bring Your Own Account. It's a much more efficient way to deploy a managed service. You get the benefit of a managed service, and you get the efficiencies and the cost reductions when you control the cost with your infrastructure vendor. And GCP is a beta right now, but AWS is their GA full-blown solution for you guys to use. And I think we released this year Scylla 4.0 and Scylla Enterprise 2020. A lot of goodness, really. Lightweight transactions. Right?
It almost didn't fit in the slide.
It didn't fit in the slide, I agree, because I had to go and put some commas and brackets to put all the items that we have done there, but I just want to make sure that we hit the highlights. So user-defined functions, DynamoDB compatible API, the alternative project. Again, think about different APIs you can use with Scylla. Encryption at rest for those enterprise users who need those capabilities, both as a in-server key, or you can use a KMeep server to interact with those rotating keys that you need to deal with. Change data capture, CDC. If you have any type of a streaming solution that you need to get data in and out from a database, or transactions that change database out from it, there is a CDC options within Scylla today. We did a lot, but a lot of usability, performance, and stability features into Scylla. One that is extremely helpful for those who are familiar with Cassandra, row-level repair, really minimizing the impact of repair process on your overall workload. There is minimal to no impact when you run repairs, making sure that we tune properly the repair process into the most granular possibility, which is a row-based system. We have added the like operator. So if you have a search like workload that you need to do, for example, if you're searching for a specific part of a text inside an index column, whether it's a partition key or a clustering key, you can use the like operator to find out the rows that match that specific use case. We have detectors for both large and cell detection, so you can make sure that you don't oversubscribe the Scylla system to resources that it cannot provide you at the end of the day. And other things that we added is IPv6. So if you're moving to a new networking system, feel free to use it. As I said, workload prioritizations, a lot of benefit for multiple users using the same system on and on. And ICS, incremental compaction strategy. If you think about it, the amount of data you can save with incremental compaction strategy is amazing. Think about using almost 80, 85, maybe 90% of your disk space for actual data. You don't have to store anymore 50% of your disk for compaction processes, and the compaction process is less impactful on your system, less CPU consumption during the process of compaction. Again, part of the Scylla Enterprise offering that we bring in today. Now, if you liked all this goodness, what I can ask you is do the following. Talk with us. Okay, so the professor here, the guy who has all the tricks and sticks to solve the problems, and me, if you need some resources, are available for you. If you need any other question, if you need 24/7 type of connection with us, we have an amazing Slack channel for our users. Punch yourself in. There's a lot of good discussions. Some of them are more fun than others, I must admit. Others are a little bit more serious, but in any case, you'll be able to get the benefit of using Scylla and enjoying our community, which is growing every day. Feel free to reach out to us. We are happy to help people day in and day out. And as I mentioned in the beginning, we have our upcoming Scylla Summit January 12th, 13th, and 14th. It includes a full training schedule. So there is training from our VP of Engineering, from our professor here about Kubernetes. We have demos that Mahi is building up. There are other items that, for example, a full understanding on how to use Scylla from an operator side, a full session about alternator, the DynamoDB compatible API. All those sessions are in the Scylla Summit. So I, again, ask you to register, join us. It's free. So there is no excuses. You don't have to ask for your boss for approval on the expense. It's just sit there for 3-4 hours with us. It's going to be fun as well from our side. And with that, I think we have a few minutes, really a few minutes just for Q&A. And we'll start with that one. Give me a second. I'll go to the Q&A questions here. I see. Okay. Okay. So, okay. So I see that somebody's asking. There is a, how does Scylla fit in the NoSQL market? So we offer a solution that is today answering users who need an efficient deployment of Cassandra and DynamoDB. If you are in the market for looking for a NoSQL database that is based on the DynamoDB paper or the Big Table paper, you should look at ScyllaDB. Scylla will provide you the most efficient, cost-effective solution out there. If you need to scale up, if you have beefy machines, you'll be able to condense yourself. We mention it on our workshops time after time. A use case, for example, from Comcast and Fanatics, who are able to reduce their cost by over 50% in money-wise, but it's more than just the cost of servers. Think about the operational cost savings. Think about the number of nodes that they had to deal with. Comcast went down from over 950 nodes to less than 80. It means that a completely different scale of operations, different scale of team that you need in order to support that operations, and it gives you much better understanding of, okay, how much capacity do I need to build for my next use case? How much resources I have to bring in for my next one? This is why I think Scylla has that edge on the market that you have there.
Yeah.
Go ahead.
I would summarize everything like, so basically performance, we're there. Innovation, you can see with the new APIs, with things like workload prioritization, we are just upping the game, all the time. And if you don't believe us, ask our users, ask our customers. It's all there.
Yep. Another question is, you mentioned AWS and GCP. What about Azure? So we have users deploying Azure today. On Azure, we recommend the LSV2 instances that Azure has there. Those are, again, NVMe-based instances with a lot of CPU memory. Really helpful. We get the benefit of using that. We have multiple users on Azure today as well. If you guys mind.
Yeah. If I may add to that, I mean, basically, Scylla is an asynchronous platform. So, any request your client makes to the server, and the server response is asynchronous. So, in a system like this, your bottleneck is almost always going to be storage. Storage is always going to be a bottleneck. So make sure you're picking NVMe disks. It could be any flavor of instances. In Azure, obviously LSV2 are the only flavor right now that are available. They're adding more and more flavors as well in Azure. But even in Amazon, if you're doing C5Ds, M5Ds, or i3 and i3EN. And any flavor of instances which have local storage, because you want to have that really good throughput from your network and from your disks. So if you use local storage, you should be good.
One more last question that I'm going to be answering here. It's about secondary indexes. So what is the difference between secondary indexes that exist within Scylla versus regular secondary indexes? I don't know, Moreno, you want to take it? I'll take it either way.
Well, first we have two types of secondary indexes. We have global secondary indexes and local secondary indexes. basically it's all about data locality. Global secondary indexes, they will reside, sometimes in different nodes where your original data resides. Local secondary index, they will always be on the same node, which you will, save you one hop to read that data. And of course, the indexes, they're using materialized views underneath. Maybe I'm going too deep into this, but basically it's using all of those items that we presented for the Scylla architecture to our advantage. So basically, they're very efficient.
Yep. Create index on a column that does not have an index on it, and you'll be able to benefit from a searchable index.
There is a small difference though, right, Eyal? I mean, if you're creating a materialized view versus a secondary index, because materialized view, it's another table that gets created versus the secondary index, even though it is another table, syntactically from the client, it doesn't matter. You just still call the same thing.
Much easier, because it looks, for your application, it looks like you're going to the same table, right? So.
And the secondary index table is actually smaller than the whole view if you get a full-blown view. Yeah, that's another thing that we have to look at. That's I think brings our time up. We have a couple of more minutes here. All I want to say is thank you guys for having, staying with us for this amazing year. Challenging to some of us, more fun for others. In any case, we hope to have a better and a more amazing 2021. So I encourage you again, go to our Scylla Summit, register to our workshops that we publish every other week. Those are Fridays, 10 a.m. Pacific. We'll probably add more times and more content to those workshops. So by all means, join us for those sessions. I want to thank you, everybody, Moreno, Mahi, for being with me for this amazing year.
Yeah, great audience. Thank you, everybody. I had a lot of fun. I hope you had too.
Yeah, and I think prizes are going to be sent out.
Yeah.
Slides and recording.
Just mention on the chat. We'll reach out to the winners.
Have fun, guys. Have a great end of the year. Try to celebrate
Cheers.
and enjoy yourself.
Cheers.